Hello, my name is Chris and I want to present you with some grinding mill basics and the current situation on your grinding mill. Okay, let's consider the basics of a grinding mill used for comminution or so-called grinding. A grinding mill consists of a cylinder shell with a certain length L and certain diameter D. If the ratio of the length over diameter or L over D is between 1.56 and 1.64, the grinding mill can be considered as a ball mill. Other ratios smaller may be considered as a sag mill, and larger may be considered as a rod mill. Bolted to the shell would be the feed trunnion, which is orientated at the feed side of the mill, and the discharge trunnion orientated at the discharge side of the mill. For the mill to establish overflow, the discharge trunnion opening would be larger than the feed trunnion opening. The mill shell is fitted with a set of liners for shell protection and also assist with ball trajectory during grinding. Feed material enters the mill through a feed chute and exits the mill through a discharge strommel screen, which screens the mill discharge from scats and debris. The screen is also important for protection of pumps. To drive the mill and provide the power needed for grinding, the mill is fitted with a curve gear and pinion drivetrain combination. The installed electrical motor determines the installed available power for grinding. It must be noted that the installed motor power is an available potential power less drivetrain efficiency. In a nutshell, this explains the physical parameters of a grinding mill and 3 points that is important to remember. The mill is classified by the length and diameter ratio. To establish overflow, the discharge opening must always be larger than the feed opening, and the actual power available for grinding is the total installed motor kilowatt less drivetrain efficiency. As a last addition, maximum grinding power is a function of grinding media volume, meaning that the installed motor kilowatt must be able to accommodate maximum grinding power. For the purpose of process control, it is important to understand what the control parameters of grinding mills is. Due to the fact that the grinding mill is classified as a simple machine, it basically only has 2 control parameters. Firstly, grinding kilowatts, and this is directly proportional to ball load. And secondly, ball trajectory, and this is directly proportional to mill RPMs. And for efficiency, this can be controlled between 50% to 75% of the critical speed of the mill. From my past 20 years experience in installation of comminution mills, I often get the question from the client, why does my mill not grind? And the reply to this question is actually very simple. Junk in, junk out. I will explain this statement with the following facts. Fact 1. A grinding mill is classified as a simple machine. It will grind anything you give it to grind. It's got no intelligence, and once the feed to the mill stops, it will consume itself. It will start consuming its grinding media. It will stop grinding once you stop the mill. It is built to grind. Fact 2. A grinding mill has no ability to distinguish which portion of the feed it must grind and which portion of the feed it must not grind. It doesn't have any selective ability. It cannot select between different portions. Selection of the feed material to be grind must take place prior to grinding. Fact number 3. The available grind kilowatt is equally distributed over the entire volume of the feed distribution. For example, in a situation where we have a poor selected distribution with a large portion of fines with the coarse material to be grind, the grinding kilowatt is equally distributed by volume and end up with an undergrind coarse material and unnecessary and wasted overgrind of fines with a poor grinding result. In a situation where we have a good selected distribution feed with a small portion of fines, most of the grind kilowatt is applied to the coarse material with a good grinding result. Let's recap on the 3 important facts of effective grinding. Fact 1. A grinding mill is a simple machine. It's got no intelligence. Fact 2. A grinding mill has no selective ability. It can't select which of the feed to grind and which of the feed not to grind. Fact 3. A grinding mill has an equal distribution of its kilowatts over their entire volume. From these facts, we can summarize that the most important thing for effective grinding is a classification of feed prior to grinding. Currently, we have a single-stage cyclone with a cyclone feed of approximately 49% solids, which of the total volume, 34% is fines and 17% is coarse. We have a good but small selection of underflow with a solids ratio of about 78%, which of this underflow volume, 66% is coarse and 12% is fines. After the grinding mill, we have a good reduction of a solids ratio of 73%, which 48% of these are fines and 25% of these are coarse. Although the grinding is good, our selection is small, with a small impact of the total fines, and there is still a large portion of coarse that bypasses the mill.